Hello, happy Tuesday. It's Miss Fenton from Stevenson High School, and welcome to day 2 of our discussion on memory and cognitive psychology. Today, we are going to start right away. We're going to get right into it. We're going to review that FRQ I gave you yesterday, and we're going to talk about retrieval and the biological basis of memory. So this was yesterday's FRQ, and this is an actual study. Obviously, the abstract, even alone, is much, much longer than this. So I just shortened it up to hopefully get the main idea here. And when you take the AP exam, you're going to have 2 questions. One's going to be concept application, like the one we went over yesterday, and that'll have 8 tasks, and you'll have 25 minutes. The research question will probably look something like this. You'll have some sort of research study. You might have an image even to look at. And then you're going to have 6 tasks, all related to research. Or I could have given you a concept application term in here. I could have thrown in, for example, agonist drug or antagonist drug, or just acetylcholine itself. So let's take a look at this step by step. The first question was, what is the operational definition of the dependent variable? And I put in a definition here, but this is an example for sodas. You wouldn't define operational definition and dependent variable and then explain it. So the second part on the bottom, the dependent variable in this study is the amount of time in minutes that it takes the rats to complete the maze. And for this to score, you have to operationally define it. You can't say how long it takes the rats, right? You have to be really specific. How long does it take in minutes, in seconds? I guess hours if it's a really, really long rat maze. But the dependent variable is the effect in a cause and effect statement. If you have a hypothesis and you say, if this, then that, that's what follows the then. So if you had a hypothesis, if you drink Red Bull, then you will dance better. Dancing better would be the dependent variable. Unfortunately, just saying dancing better is not operationally defined. In order for it to score, you need to actually indicate how that would be measured, be very, very specific. So if it doesn't say, if the question prompt just asks you for the dependent variable, you should still always operationalize it. And operational definitions of the dependent variable are critical for replication, and it is really important that you write it in a way that is completely measurable. So with something like this, a rat's going through a maze, it's easy to come up with like time in minutes or seconds. If it was dance better, that's a little bit more abstract, but you would still have to make it measurable. Dance better as measured by fewer errors in Dance Dance Revolution, or how well they danced based on a scale of 1 to 10 from a dancing judge. So you need something specific and measurable. Okay, what type of descriptive statistic could the researchers include regarding the dependent variable? So a descriptive statistic is a measurement used to illustrate the data without making inferences about generalization of the results to the greater population. And there's lots of examples of descriptive statistics. You could use any of the measures of central tendency. So I used a mean here in the first example. You could use median or mode potentially, as long as you related it to that dependent variable, which is the amount of time it took the rats to finish the puzzle, finish the maze. You could also use the standard deviation. And if you look with that extra sentence here, I actually at the end, this would allow the researchers to account for outliers that might distort the mean. If you want to go a little deeper, be a little more specific, but you need to make sure you use a descriptive task. So what you couldn't use here, which would not score, would be something like a t-test or an ANOVA. Those are both inferential statistics. And those are statistical measurements that are used to mathematically determine if the results of a study can be generalized to the larger population. So in this case, you needed a descriptive stat, so mean, median, mode, standard deviation, measure of variance, the range, all of those would have worked. You could have even actually described, for example, like a bar graph, as long as you related it to the dependent variable. That's that apply. You got to be specific and answer all of the pieces of the prompt. Okay, what could be concluded if the results were statistically significant? Statistical significance is a really important concept that you need to have a really strong understanding of. So if the results of an experiment are statistically significant, in this case, right, that would mean that the rats in group 2 were able to run the maze faster than the other rats because of the independent variable, because of that drug, and it wasn't just due to chance. So when you see when you're looking at statistical significance, it might be presented in the form of a p-value. So you might notice that p is less than 0.05, and that would result in a statistically significant result. But if you are asked to describe statistical significance, just simply saying p is less than 0.05 would not be enough. You have to explain it, right? The next one was a control variable. So this is about the steps that researchers take to get rid of confounding variables. And one way they control, of course, is random assignment. But the confounding variables, the way they got rid of it here is all three groups of rats would have had the same maze, because you wouldn't want the reason that group 1 or 2 ran faster or slower to be because of the difficulty of their specific maze. So researchers would give them all the same maze. Maybe they would all do this at the same time. They would all have the same amount of practice time. Everyone in each group would have the same amount of the independent variable. What you don't want to write here is talk about the control group, right? The group that received no injection. That's a little bit different than a control variable or a control in the study. Okay, indicate a strength of the research design used by Martinez and Kestner in this study. So certainly it's an experiment. So an easy answer, potentially you could have gone with, is that because there's random assignment, because it's a controlled experiment, you could make a cause and effect conclusion. But you could also have answered in these other ways too. So you might have looked on the ethics piece, right? You could talk about how it's easy to replicate. This is a fairly simple design that could be redone multiple times. Okay, explain a conclusion that can be made from the results of this study. So for example, researchers could conclude that acetylcholine improves memory formation because drugs that increase its transmission improved memory, and the drugs that blocked its transmission impaired memory. So there's a bunch of different ways you can do this. And if you take a look at the note, you have to somehow indicate that it was a cause and effect statement, because this is an experiment. You need to not necessarily say this causes that, but it has to be causal language and not correlational language. So I'm going to slow down here. Maybe you want to take some notes. Causal language would be phrases like, of course, causes and effects, but also maybe functions, impacts, improves, increases, decreases. If you have a correlational study and you're looking at maybe a scatter plot and you're interpreting those results, you would want to use phrases like related to, connects, is associated, tends, links, predicts. So you want to make sure if it's a research study, you use causal language in your conclusion. And if it's a correlational study, that you don't use cause and effect language, because correlation is not causation. You want to stress instead the relationship and use those relational languages. So you might want to take some notes, write some of those buzzwords down so that you don't accidentally infer causation when you're describing, say, a correlational study. All right, take a quick look overall at your answer. Did you space it all out? Do you have 6 separate sections? If you only had, 4 paragraphs or 4 sections of text, then maybe you skipped a question. Hopefully you answered in order, and you definitely applied. And most importantly, you want to add slowly, timing yourself. Okay, today we're going to talk about memory as well, and we're going to focus on retrieval. And so this is a picture of my sister's dog, and this is Kaya. She's retrieving. And oddly, Kaya only retrieves in the water. She doesn't understand how to play fetch on land. Not sure how that happened. Okay, encoding, storing, and retrieving. So this is memory, and it can be seen as this process of encoding, kind of typing things on your computer, for example, storing, hit save, and then retrieving, pulling it out of memory. So memory, again, is cognition involving encoding, storing, and retrieving of information that leads to persistent learning over time. So yesterday, we kind of filled in a bunch of things that fit under encoding and storing. And some of these concepts can go in more than one place too. With retrieving, this is taking information out of your memory system. And broadly, you have recalling and recognizing. So with retrieving, it's taking it out. With recall, this is reproducing learned material from scratch and adding a bunch of details. So this might be like an FRQ. If it were maybe a real world example, maybe if you were a witness to a bank robbery, it would be describing the appearance of the suspect to the policed artist, right? So you're trying to recall as much detail from scratch as possible. Recognition is picking out the correct answer from choice. So that's more like a multiple choice test. Or maybe if you were a witness to a crime and they showed you a series of photos in a lineup, it would be trying to, recognize the individual if they are in fact in that lineup. So lots of strategies for memory, including mnemonics. And so sometimes we use mnemonics that are kind of first letters keywords. So with this mnemonic, SAME, you can remember that sensory nerves have afferent nerve fibers, SA, and then ME, the motor neurons have the efferent with an E nerve fibers. You could also try something called a peg word mnemonic, and this is a little bit more sophisticated, but it's actually very, very effective. And what it does is it allows you to memorize a series of words, especially ones that you want to remember in order. So what you first do is you memorize the pegs, which are numbers and words that are connected by rhyme. So it's like 1 is a bun, 2 is a shoe, 3 is a tree. Then what you do is you take your list of items to remember and you hook each one kind of on a peg. So you're going to put the first item on that peg, 1 is a bun, and connect it with imagery and elaboration and both elaborative and maintenance rehearsal. And I would suggest potentially you go to this YouTube video and you listen to Dr. Michael Britt of the Psych Files. And in this video, he will teach you the 8 Erickson stages in order with peg mnemonics. So if you've already watched this video, it takes about 15 minutes. It enables you to really grasp the 8 stages in order. So for example, if you were to just give me a number out of the 8, if you were to say 3 is a tree, I could immediately go to initiative versus guilt, because I can imagine what Dr. Britt's imagery is. So in that one, there is Shia LaBeouf in a tree and there's a quilt. So you're going to have to watch it for yourself. But it does allow you, like if I want to think of the 5th stage, I don't have to go 1, 2, 3, 4, 5. I can go directly to 5 is the skydive, and I would say identity versus role confusion. You can also do a method of loci, which is sometimes called a memory palace. And this is connecting a series of items you want to remember with a series of locations in a familiar place. So maybe rooms in your house, your path through your school day, your neighborhood. Okay, some retrieval cues. So we have this broad idea of the encoding specificity principle that says that retrieval, like pulling stuff out of memory, is easier if you are if you're getting these certain hints, right, like place or mood or state, that is similar when you're retrieving as when you first encoded them. So let's look at a few examples of encoding specificity. There's the serial position effect, which is that if you have a list of items to remember, we have a tendency to remember best the beginning and the end. If you remember only the beginning of a list, we call that the primacy effect. If you remember only the end, that's the recency effect. And if you remember both, you can call it serial position or primacy recency. So it's sometimes like, it's important if you're making maybe a sales presentation that you want to put your important information, your best ideas first and last. You can take this with a list on a website that you create, or maybe in a debate or even a legal argument. You want to think about the serial position effect. There's also something called the von Restov effect, also called distinctiveness, sometimes isolation effect. And this is that unique items in a list are stuff that we remember. So if you have a long list of things to pick up at the grocery store, and then there's like one kind of strange item that you have to pick up, like kind of really atypical, you might find that you remember that. Next, we have priming. So priming, as we talked about yesterday, is a type of implicit memory. It's an implicit long-term memory, but it's also a retrieval cue. So you have this implicit memory of a stimulus that helps you, remember better. So this study here that's being depicted in this image with the rabbit is they showed participants, or they told them, they use the word rabbit, right? And that's activating the concept, and you're going to have this kind of implicit memory of hearing the word rabbit. And then later they asked them to spell the word that was said out loud. They said the word hare. And participants were more likely to spell it H-A-R-E, connecting it to another word for the word rabbit, rather than the more commonly used word hair, H-A-I-R, because of priming. We also have another series of retrieval cues, though we have context, state, and mood-dependent memory. Context-dependent memory is that information that's encoded in one kind of location or place or environment is best recalled when you're also in that same environment. And this study here with this scuba diver was from Alan Badley. And he found that when they had divers learn a series of words on land, they recalled those words much better when they were on land. And if they learned the words underwater, they were able to recall those words better in that same environment, that same context. And you might experience this in real life. You leave for school in the morning and you tell yourself you're going to stop and pick up, toothpaste or milk or something. And you get home, you've never stopped for the milk, but the second you walk into the kitchen and you're back in that context, you see the refrigerator, you're like, oh, I forgot the milk. You might have had the same thing happen with a permission slip. Your third-hour teacher gives you a permission slip for a field trip, and you take it home, and you don't have it signed, you don't even think about it, but the second you walk into third hour and you see that context, that same place where you encoded that memory to do something, you suddenly remember. Now, when you're studying for your AP exam, because you're going to be taking it at home in most cases, you might want to practice studying in the same place and the same way that you will be taking the exam, so that hopefully that helps with your encoding. Now, a state-dependent memory is about an internal, like physiological condition, like it might be hunger or thirst or pain, and that might be correlated to recall. With mood as a retrieval cue, this is about emotion. So it's an emotional state. So maybe if you are in a happy mood, you're more likely to think of positive memories. And maybe if you are in a sad mood, if you're feeling down, it might be difficult to remember happier memories. Another example of context-dependent memory might be if you ever go back and visit your elementary school, you might find that you suddenly start having memories come back to you from like second grade that you haven't thought about in quite some time. Okay, now let's talk about the other side, the flip side, like forgetting and memory distortion. And forgetting is operationally defined as an increase in the number of errors when trying to bring back material from memory. So if you needed an operational definition of forgetting, you might phrase it that way. We also talk in forgetting, we talk about retention, the proportion of material that's retained or remembered. And relearning, the process after a loss of learning of reacquiring knowledge that has been forgotten potentially over time. So what you have here are a bunch of nonsense syllables. These are consonant vowel combinations that Ebbinghaus used when he was studying memory and studying forgetting. So take a moment and read through this list a few times. If you're watching this on recorded video, you can pause longer and practice a little bit more, but just for a demonstration's sake, how many of them do you remember? So this is essentially the study that Hermann Ebbinghaus did over and over again. He was a German psychologist, and he was one of the first people to study learning and forgetting really systematically. And what he came up with is this idea of a forgetting curve, like how fast individuals learned and how fast like that information went away. And he did a case study, right? He basically had one subject in his research, and that was himself. And he did this repeatedly. He was the only subject, and these are nonsense syllables, right? They can't be a word. So probably some of these wouldn't be as good as others, but like you wouldn't want to just spell, say something like cat, because cat has meaning and associations that might be easier to remember. And he also studied something called the forgetting curve, which is the amount that's lost over time graphically. And he also studied methods to overcome that forgetting curve. So here's a great image of his forgetting curve, and you can see that giant drop, and that happens mostly in the first day. how much learning you lose. So Ebbinghaus's graph of how much information is lost over time. And the biggest drop in forgetting is within the first day after learning. You have this steep drop, and then eventually it kind of levels off. So basically, the bottom line is forgetting happens quickly. The day after learning such a list, when Ebbinghaus was practicing this, he had a steep drop in his retention. But it wasn't completely gone. There is some retention there. So Ebbinghaus, as I mentioned, also studied how to overcome the forgetting curve. And it starts with rehearsal. So Ebbinghaus found that the more times he practiced the nonsense syllables on day 1, the less time it was required for him to relearn it on day 2. So that brings us also to time spent. So the more actual minutes, hours you spend studying, he found that the more time spent learning was correlated with less time spent relearning. So if you look at that, what type of correlation did Ebbinghaus find between the amount of time spent rehearsing or learning and the time needed for relearning? What's the direction? And you can maybe estimate the strength of that relationship. Like if we were to graph it on a scatter plot, what would that come up with? And this is a negative correlation because the variables are going in different directions. So the more time you spend studying or learning, less time was needed with relearning. So on a scatter plot, that would create a correlational slope that was kind of sloping down. And in fact, Ebbinghaus found that this negative correlation was really strong. It was close to negative 1.0. It was not linear, but getting there. So it's really strong. So that's something to think about. You get out of studying kind of what you put into it. And the other thing is that relearning is faster. And the more time you study and the deeper that you go the first time, especially with, say, elaborative rehearsal, relearning will be easier. So relearning can be used as a measurement of memory retention. So if you were to create an operational definition for relearning, what might that look like? How could you measure, quantify relearning? You might want to say the amount of time in minutes it takes to remember or relearn a list of 20 words that had been forgotten. So you want to have that time and then be specific, say in minutes or seconds, days. Okay, the other thing he talked about, so another tip from Ebbinghaus is this idea of overlearning. So this means that you're going to keep rehearsing material even after you've mastered it. And that's how you overcome this forgetting curve. And I think overlearning, it sounds kind of negative, but overlearning means that once you can do it, once you've mastered something, that you keep rehearsing anyway. And if you think about it in terms of like sports or performing, overlearning is something you just accept, right? If you are a member of the dance team and your school's dance team, your coach has you run through the routine, the first time the team completes the routine perfectly, it's not like practice never happens again. Right? If you play a sport, maybe you play field hockey or soccer or basketball or football, the first time the team runs a play effectively, the coach doesn't say, well, my work here is done. You guys can just go home. We never have to practice again. You're going to keep practicing anyway. You're going to overlearn. And what that does is it helps really make a durable memory and also helps you overcome stress, right? So when you perform in practice, it's very different than performing in front of a large crowd. And having overlearned that routine will help you to be successful. So you want to overlearn when you study academically. It's no different. He also studied the difference between distributed practice, spaced learning, and found that it's more effective than massed practice, which everyone calls cramming. So distributed practice is learning by spreading out your studying over time, doing a little bit each night rather than one giant cramming session. And distributed practice can help with a lot of things. It reduces boredom. It's definitely better for more complex tasks. More complicated learning works better if you do this. And most importantly, it creates more durable storage than cramming and better retrieval. So Ebbinghaus recommends both distributed practice and overlearning to overcome that forgetting curve. Now, comment a little bit about massed practice or cramming. The problem for teachers is that it actually does work. This is the thing. So if you've ever crammed for a test and had success, that's great. I mean, it can work. The problem is you have to make sure that you wait to the last minute. Now you're cramming. What if something happens and you suddenly don't have the time that you need? So that's a potential problem. It takes a lot of concentration and motivation to cram, and it's less durable storage. So if you were to cram all year long in AP Psychology for every quiz and for every test, wait to the last minute and cram, even if you were successful, what's going to happen is by the time you get to a semester exam, a final, or an AP exam, that process of going back and relearning, because you learned initially through mass practice, is going to be much harder than if you had distributed your practice. And you have lots of time. The AP exam is not until May 18th, so distribute your practice. And you might even want to interleave your practice, study a little psychology, then maybe study a little government, or maybe another course that you're working on, and kind of put a little extra challenge to your brain. So speaking of testing, Ebbinghaus talked about, I'm sorry, not Ebbinghaus, but the testing effect is a well-documented phenomenon. So encoding is more effective and your memories are stronger. Your long-term memory is more durable, it's easier to retrieve if you quiz yourself and if you rehearse. Especially if you elaboratively rehearse. And this is much better than, say, just rereading your notes or rereading your textbook, or taking out your notes and highlighting it in a bunch of different colors. So testing protects your memory from the harmful effects of stress, right? Because you've already practiced this. This, by the way, again, is another dog retrieving. This is my friend's dog, Umi, and she's retrieving as well. But take advantage of those FRQs with rubrics that are on AP Classroom. Take advantage of the provided FRQs that we give you at the end of each of these videos. Really test your knowledge, and test your knowledge under testing-like conditions. So take into effect that context-dependent memory. So a couple other types of memory errors. We talked yesterday about the tip of the tongue phenomena, and we talked about ineffective encoding or encoding failure. Maybe you didn't pay enough attention. We also sometimes forget just because of decay, right? The theory that forgetting occurs, like memories, if you don't keep retrieving them, they kind of disappear over time. They're still there. Long-term memory is generally permanent. That memory is there. Just because you can't retrieve it doesn't mean it doesn't exist. So the last three, interference, amnesia, and motivated forgetting, are a little bit more complex. So we're going to go over them in a little bit more detail. But also just want to point out here with a little tip that tip of the tongue and encoding specificity principle, like these ideas highlight that retrieval cues are important for retrieval. And another tip, whenever you see the word cue, it just means like a hint, right? So a retrieval cue is a hint for bringing something back out of memory. In sensation and perception, you have both monocular and binocular cues. And what those are, they're hints. So if you have a monocular cue for interposition, that's a hint. It's going to tell you when, it's how your brain knows when an object is close versus far. Okay, so interference. With interference, this is about blocking. So if you're writing an FRQ about interference, whether it's proactive or retroactive, at some point you have to say blocking, like that's your synonym for interferes. So proactive, with proactive interference, what's happening is the reason why you're forgetting, the reason why you're having a memory error is your old information is blocking your recall of the new. So you can remember the old password, but it's blocking the new. With retroactive interference, it's going the other direction, right? So new information is blocking your recall of old. And if you have to write an example, keep it simple. Go with like a password or a phone number. So with proactive interference, you can't remember your new phone number because all you can think of is your old one. And then retroactive, the opposite. So here's another little tip. So if you want to kind of write out proactive, and the first two letters PR are also in previous. Old blocks new, you can't remember the new. New blocks old, can't remember the old. So with retroactive, you have RE for recent. FRQ tip. Interference applications in an FRQ response have to indicate that the retrieval problem is the result of blocking. And so if it's proactive, old is blocking new. If it's retroactive, new is blocking old. And you have to kind of indicate what information is old and what's new for the reader. So make sure that you're really clear in your description. So I'm going to give you an example here. This is a example of proactive interference that would score. So your old memory, you're clearly defining what's old and what's new, of the Pythagorean theorem is preventing, or blocking, which is interferes, you from remembering more recently learned formulas. Now, if you look at this one, you can remember the Pythagorean theorem that you learned in 8th grade, but you can't remember recently learned formulas. So on the surface, it seems like proactive interference, but it's unclear, right? And it's unclear because it doesn't talk about that blocking piece. You can remember the Pythagorean theorem, but you cannot remember the quadratic formula. This is incorrect, right? It doesn't have the blocking piece, and it's not even clear which is old and which is new. So that's interference. So interference, the memory is there, but something is in front of it, right? So you're looking for something in your addict, it's there, but something's blocking you. Amnesia, on the other hand, is the partial or total loss of memory that's due to like an injury or an illness, right? So this is an injury, it could be a brain disease like Alzheimer's or stroke. And it's those things, what happen is the disruption might be a temporary loss of blood supply, it could be the destruction of neurons. And we have these two types of amnesia. So you have retrograde amnesia, which is a partial or complete inability to remember events that happened before the trauma or disease that caused the illness. And with anterograde, it's the other direction. It's the partial or complete inability to create new memories after the trauma or disease that caused the amnesia. And both of these can be, maybe you have an injury, there could be an injury and there's a retrograde amnesia, but it's only for like a few minutes, right? If it's a very serious injury, it might be, weeks or months or years that are lost. And it's the same with anterograde. It could be just a loss of memory for maybe a few minutes after the injury or illness, or it could be very lengthy, right? So we talked about in an earlier video, patient HM. So this individual had a surgery that involved removing their hippocampus, and the unfortunate, tragic result of that was that this individual had very severe anterograde amnesia and could not make, new memories. But that's a very extreme example of amnesia. There's also dissociative amnesia, which is memory loss involving like autobiographical information that's usually due to psychological causes. But when we're talking about retrograde and anterograde, this is like illness or injury. So here's some little tips here. So with retrograde, retro means before and antero means after. And so that's what you can't remember. So you can also think of patient HM. He's your kind of extreme example of anterograde amnesia. An FRQ tip for amnesia on FRQs is that you have to indicate that the memory loss is due to injury or illness versus interference where the memory loss is due to blocking. Motivated forgetting is the conscious or unconscious act of eliminating painful thoughts from experience. Now, for Freud, this would be repression. This could be, motivated forgetting a paper deadline or a dental appointment. With Freud, it's unconsciously pushing these unacceptable memories or thoughts into the unconscious. But modern psychology doesn't agree with Freud. Very, very painful events, people unfortunately actually do remember very well. Victims of crime, they don't repress that. Modern psychology does, however, acknowledge that individuals do push upsetting thoughts away from your kind of immediate awareness, and that would be like motivated forgetting. Okay, one of the researchers that they want you to really know in cognitive psychology is Elizabeth Loftus. And in her 1974-75 studies, she talked about and studied the misinformation effect and false memories and the problems with eyewitness testimony. She's an expert witness in those areas. So what she did in this experiment is her initial experiment, she had 45 students and they all watched a video of a car crash and they answered questions. And I think they had to write a report, like an account as well. But the key question, the one that mattered, was the estimate of the speed of the vehicles during the accident, right? And what she did is she randomly assigned these people to 5 conditions. And the independent variable, what was different between the conditions. So if you look here in condition 1, they all watched the same video, but they were asked how fast were the cars going when they smashed into each other. She asked another group collided, bumped, hit, and contacted. And then on this page, I also have the results, right? So this is the group mean of the estimated speed in each group based on the verb in the question. So the little research review, what are the levels of the independent variable in this study? And that would be the 5 different verbs, whether they were asked hit or smashed or collided. If you had to give an operational definition of the dependent variable, remember you want this to be measurable. First of all, you have to identify the dependent variable and then make it operational. If you're watching this recorded, you can always go back and reread the screen if you need to see a little bit more time. So this would be the estimated speed in miles per hour of the vehicles when the accident happened. How could Loftus and Palmer do random assignment? And you remember, you need random assignment if you're going to have cause and effect conclusions in your experiment. So she's got her participants, and she would have to maybe use a random number generator and use that to place participants by chance into one of the 5 groups. Okay, make a conclusion based on her results. Like, what could you say? And remember, this is an experiment, so you probably want to try to use things that sound cause and effect, right? The phrasing that was used, the leading question, smashed or collided, created this change in the speed estimate. So the use of the verb, which is the independent variable, distorted memory. The memory of how fast cars were traveling could have been distorted by the verbal label used. Now, she did a second study, a follow-up study, and she had a bigger sample. And with this one, they all watched the same 1-minute video. And again, they asked them some questions at the end. And the key question here, okay, so the 3 conditions had the different verbs, but the key question here was, did you see any broken glass in the video? Now, these people are doing this later, right? So they watched the video of the car accident, they were asked questions, and then 1 week later they come back. Did you see any broken glass? And it's important to note that there was no broken glass in the video. And then you can see the percent of people who had this kind of false memory. And it did seem to vary with the verb, with the independent variable. So a conclusion here might be that participants who were asked to estimate the speed using the verb smash were more likely to erroneously report seeing the broken glass as a result of that leading question. And here you're going to have to Another area of memory is this idea of source versus reality monitoring. So one of the things that the way our memory works is we're a little bit better about remembering the fact, the semantic piece, and not like where the memory came from, like the source or the origin. So when you source monitor, it's when you're kind of determining where you heard something, where you got this memory. So your friend tells you a joke. They come up to you and they're like, hey, I have a joke. And maybe they make a source monitoring error. And when they tell you the joke, you're like, okay, I told you that joke last week, right? So it's easy to happen. It happens all the time. Like, we forget the source of the information. If you straight up can't remember where you learned something, that's a concept called source amnesia. So if you can't remember who told you about your friend's acceptance into college, if you don't remember where you heard that, you might have source amnesia. If you're making an error, right, you think that you saw something on the news, but you actually saw it in a comedy TV show, you confused your source, you made a source monitoring error. Reality monitoring is, does the memory that you have, did it actually happen? Was external, or was it just your thoughts? So maybe you have a memory that you had your permission slip signed, but in reality, when you look at it, it's not signed. So what you were remembering was your intention to do that, and it didn't actually happen. Okay, I want you to take a look at these and identify the type of memory loss. And we're going to have to speed this up so you can always pause and give yourself a little bit more time to read. So in example 1, you have retrograde amnesia. So this is an individual who can't remember what happened just before the fall. Example 2, this is proactive interference, right? So the old combination is blocking her recall of her new. Example number 3 is just regular decay. I mean, there's no evidence here of a brain injury or an illness. There's no evidence of like something's blocking something else. This is just a loss of a memory over time. Here's a couple more. Example 4 and example 5. Again, if you're watching this, you can pause and give yourself time to read. First example is retroactive interference. This is blocking. And example number 5 is anterograde amnesia. Okay, we still have to cover biological basis of memory, and there's some key structures. So you probably remember that the hippocampus is a limbic system structure, and that's related to encoding new explicit memories. The amygdala, also in the limbic system, is responsible mainly for strong emotions like anger and fear, and it's related to the emotional components of those types of memories. The basal ganglia is another subcortical structure, and these are this is an area that's related to both creating goal-oriented movement, but it's also involved in creating procedural or how-to memories, implicit memories. And what's happening is like the basal ganglia receives input from the cortex, but it does not send messages back out. And as a result, you might not have a conscious awareness of a particular procedural memory. If you're looking for short-term memory or working memory or recalling episodic memories, determining the order in which things happen, that's frontal lobes. So that the limbic system, the hippocampus and the amygdala, those are all in the temporal lobes. And then again, the cerebellum is a hindbrain structure that's related to implicit memories. And the loss of memories, it would be memories related to movement as well. With the, at a neurological level, we have two neurotransmitters that are associated with learning. We have acetylcholine, which was in our research study at the beginning in the FRQ, and the destruction of acetylcholine neurons in the hippocampus is related to this memory loss symptoms of Alzheimer's. And glutamate is the neurotransmitter that's associated with long-term potentiation. So the release of glutamate facilitates learning, facilitates this long-term potentiation, this process where repeated stimulation of the same neural networks is going to strengthen that connection and strengthen that learning. So glutamate is critical to the growth and strengthening of synaptic connections, and glutamate's critical to learning. Okay. Debrief and summary, we went over some retrieval methods, retrieval problems. We talked about FRQs. There's a few extra tips for you, just to remind you. And here, as promised, is this long list. This is memory kind of organized in 3 broad categories. So you can make a blank version of this and test yourself. And I'm going to leave you with an FRQ for tomorrow that you're going to go over with Dr. Swope. So this one is going to be a concept application. In this one, I only gave you 4 tasks. Remember, on the AP exam this year, you will have a concept application question that has 8 tasks. So this should take you less than 25 minutes because it's shorter. It's like half the amount of time. So take a look at these terms and make sure that you reflect on both defining and applying and relating it specifically to the prompt and how the prompt changes in part A and part B. So I hope you have a great night and look forward to seeing you in a little bit. Take care. Bye-bye. Happy studying.